Hey everybody, here is a brief video showing you how to graph rational functions with two vertical asymptotes. So the worksheet that is due on May 19th, it's on practicing rational functions. Number 9 is this graph right here, x over x squared minus 9. And we haven't formally done any problems on the videos that have two vertical asymptotes. So I wanted to show you a couple examples to clarify that. Keep in mind that we are only going to be doing graphs that have one horizontal asymptote, and it approaches the same thing on the left as on the right. It is possible to have more than one horizontal asymptote. Those types of graphs are covered in AP Calculus and AP Biology. In this class, you won't see them. You will see, though, graphs that have more than one vertical asymptote. That is fairly common, and the process is the same, but the shapes look a little bit different. So I want to show you some different ways that you can have different kinds of vertical asymptotes. It's not always just one vertical asymptote. So vertical asymptote, remember, you want to think, what would make me divide by 0? So what would make this denominator be 0? Now you might be able to look at this and say, oh, well, if I plug 3 in, then 5 times 3 is 15, minus 15 is 0. If you can't look at the denominator and see it right away, just set your denominator equal to 0 and solve for x. 15 over 5 is 3. That is your vertical asymptote, which means your domain is x cannot be 3 then. Your horizontal asymptote, since the degrees are the same, your horizontal asymptote is the ratio 3 over 5. If we look at this one here, your horizontal asymptote, the degrees are the same again, so you do the ratio of the leading coefficients. That'd be -1 over 1, which is -1. Let's take a look at the vertical asymptote though. We want to think, what would make my denominator be 0? So you have x squared plus 1 in the denominator. So think, what can I plug in for x that would make this whole thing be 0? And if you look at this long enough, you could sit here all day trying to find a value that would make the denominator 0, and you won't be able to find a real number that does it. And that's because if you set your denominator equal to 0, and this is really important to understand why, if you do the square root, the only thing that would make the denominator 0 is the square root of -1, which is I. We talked about that in the winter, the imaginary number. So we're only graphing real numbers because we're looking at the real Cartesian grid. So there are no vertical asymptotes. Now, if you have a graph with no vertical asymptote, that means the graph can go all the way from the left all the way to the right. So that means your domain, I'm running out of room here, is all real numbers for this example. For this one here, I want to think, what can I plug in for x to make my denominator be 0? So I'm just going to set my denominator to 0 and solve, and square root of 4 is plus or minus 2. Okay, so here's the first one here where we've seen two vertical asymptotes, x at 2 and at -2. So these are your vertical asymptotes, which means your domain is x shouldn't be 2 or -2, because that means you would divide by 0. One more here, our vertical asymptote in this case is x equals -6, because that would make me divide by 0, which means my domain is x should not be -6. And here I have x squared plus 6. Same denominator as here, it's just I've squared x. So in this case, you want to think, what would make my denominator 0? You can also do this algebra work. Square root of -6 is again imaginary. That would be root 6i plus or minus. That means there are no vertical asymptotes because we can't have imaginary asymptotes. So that means your domain is all real numbers again. Just to briefly review here, in this problem, my horizontal asymptote, let's see, the degree in the numerator is 0, in the denominator is 2. If the degree on the bottom is 0, your horizontal if the degree on the bottom is bigger, your horizontal asymptote is 0. In this case, the degrees are the same. Leading coefficient is 2 over 1, so your horizontal asymptote is 2. And in this case, the degree is bigger on the bottom, so your horizontal asymptote is y equals 0. Okay, so let's get to the examples here. I'm going to do number 9 and one extra example to make sure that you're totally comfortable doing this. So let's briefly get the asymptotes. The degree on the bottom's bigger, so my horizontal asymptote is 0. And let's draw this stuff in as we go. You should always draw your asymptotes right away because that would tell you what points to pick in your table. My vertical asymptote, what would make my denominator 0? Well, 3 and negative 3. If you want to do quick solving work, you can. And if you square root it, you get 3 and negative 3. X-intercept, set your numerator to 0. Well, that's just x equals 0. Y-intercept, plug 0 in for x. That would be 0 over negative 9, which is 0. So I only have a single point here, and I have 2 vertical asymptotes. All right, so now the question is, what on earth is my graph gonna look like? I only have 1 point, like is it down here or here? What's it doing in the middle? Like I have no idea what's happening. So that means we need more points. Now here's a general guideline you wanna use. You want at least 2 points on each side of a vertical asymptote. So if I want to know what's going on this side to the left of the vertical asymptote x equals negative 3, then I need more than just 1 point. So I'll show you. Let's do like negative 4. Now again, our goal is to do it without a calculator, so if you can get these points in your head, that's ideal. So let's plug negative 4, and that'd be negative 4 divided by, that'd be 16 minus 9, which is 7. So at negative 4, I'm at negative 4/7. That's like a little less than a half, negative half. Okay. I know I'm below, so I might be able to guess it's something like this. It's still good to get 2 points just to be sure, because it could cross the horizontal asymptote. Let's do negative 5. So if I plug negative 5 in, that's negative 5 over 25 minus 9 is 16. Negative 5 over 16 is almost negative 1/3. So that means I'm right here. I'm even closer to the horizontal asymptote. So the way you connect this again is you think, all right, to go from left to right, I'm getting lower. So you can assume you're going to follow your vertical asymptote. You cannot touch your vertical asymptote. So you're just going to shoot down. And as you go left, you're going to approach your horizontal asymptote. You always approach the horizontal asymptote. So I have the x-intercept of 0 here. I don't know what's going on in the middle. So let's do the points negative 1 and 1. So if I plug negative 1 in, that would be negative 1 over 1 minus 9, negative 8. So positive 1/8. And if I plug positive 1 in, that would be 1 over 1 minus 9, which is negative 8, so negative 1/8. Okay, so at negative 1, I'm at positive 1/8, and at 1, I'm at negative 1/8. So as I go from left to right, I'm definitely going down. You could do a couple more points if you wanted, but generally in between vertical asymptotes, so between 2 VAs, you need 3 points. You could do more points if you want, but 3 is generally sufficient because in between 2 vertical asymptotes, you're either going to have a cubic looking shape like we have here, or you're going to have a parabola looking shape. It won't actually be a parabola, but it'll look like it. Okay, let's quickly get 4 and 5 because I need 2 points on this side to the right of x equals 3, that vertical asymptote. So 4 ends up being 4/7, you can verify that in your head. 5 ends up being 5/16, again, you can verify that. So 4, I'm at 4/7, a little more than half. 5, I'm at 5/16, a little less than a third. So I am definitely going down. You just need a general trend, like what's happening, and then you follow your asymptotes. Okay, there you go. So let's do this one here, and then you should be good to go. It really is the same process as the others, just a few more points to do. Degrees are the same here, so 2 over 1 is 2. So now I'm up here at 2. Vertical asymptotes, I have x equals 2 and negative 2. The x-intercept, if 2x squared equals 0, then that means x is 0. The y-intercept, if I plug 0 in for x's, that'd be 0 over negative 4, which is 0. So now I can pick some points here. I have these two vertical asymptotes, -2 and 2. Oops. So I need 3 points in the middle. Well, I have this intercept, so that's 1 point. I need 2 more. I'm going to do -1 and 1. Those are easy points. I'm going to do 3 and 5. And then I'm going to do -3 and let's say -5. Again, you can pick other points if you want. I'm just going to do those. So if I go ahead and plug in -1, that would be -1 squared is 1 times 2 is 2 over 1 minus 4 is -3. So -2/3. If I plug 1 in, I'm going to get the same thing because I'm squaring. So I'm also going to get 2 over -3. So whether I have a positive or a negative input, the output's the same. So if I plug 3 in, 3 squared is 9. 9 times 2 is 18. Over 3 squared is 9. 9 minus 4 is 5. 5, 10, 15, that's 3 and 3/5, so 3.6. If I plug -3 in, because you're squaring, you're going to get the same exact output. So 18 over 5, which is 3.6. And then for 5, okay, 5 squared is 25, so 50 over 25 minus 4 is 21. 21/42, that's like 2 point something, and it ends up actually being 2.4. So 50 over 21, again, 2.4. So let's plot these, and then we can just follow the curve of our asymptote. -1 is -2/3. 1 is -2/3. I have symmetry over the y-axis. 3, I'm at 3.6. -3, I'm at 3.6. 5, 1, 2, 3, 4, 5, I'm at 2.4, so definitely a downward trend. 1, 2, 3, 4, 5, I'm at 2.4. I'm kind of going over my table here. So in the middle, you can see I'm going to have this parabolic shape because, oops, I should not have touched my vertical asymptote. Try again. Ooh, getting closer, closer, closer. I'm going up, and then I can see I'm starting to go down. I have to go down to hit that point. So this should be smoother. Here, I'm going down as I go right, approaching the HA, but I shouldn't have actually crossed it. So do your best there, getting close but not touching. Here, as I go to the left, my point went up, but I can't go through my vertical asymptote. I'm going to shoot up. Here, I'm going to shoot up. And here, I'm going to go left, leveling off at 2. So these are generally the two shapes you'll see. There's slight variations, but these are the most common types. Okay, so make sure you jot that down, and when we talk to each other in Zoom, you'll be good to go. Bye.